friends, I am Ujjwala Sahu. I am going to talk about cyclomatic complexity. What is cyclomatic complexity? Cyclomatic complexity is a source code complexity measurement that is being correlated to a number of coding errors. It is calculated by developing a control flow graph of the code that measures the number of linearly independent paths through a program module. So in this session, we are going to see how to calculate the cyclomatic complexity. To calculate cyclomatic complexity, we should know the formula for calculation. Cyclomatic complexity formula. Method 1. Cyclomatic complexity is equal to E minus N plus P, where E stands for number of edges in the flow graph, N stands for number of nodes in the flow graph, P stands for number of nodes that have exit point. As well as we will be having the another method number 2, cyclomatic complexity is equal to P plus 1. So number of predicates plus 1. So we will be going to see how to calculate cyclomatic complexity by using both the methods and with the help of one example. So I'm using here the pseudocode, which is here is given. That pseudocode is nothing but, you can see over here, if A is equal to 10, then if A is equal to 10, then if it is true, then B is greater than C. It will be going to check B is greater than C. If it is true, both the conditions are true, then it will be execute A is equal to B. Else it will be going to execute A is equal to C. And both the statement terminated over here, and then we will be going to print A, B and C's values. So here this is the pseudocode, and with the help of the pseudocode, first of all we will be going to draw the flowchart, which is very easy as we are already working with the programming languages. So the flowchart, A is equal to 10. If it is yes, then we will be going to check B is greater than C. If it is yes, then A is equal to C. If it is no, then A is equal to B. Then it will terminate the statement, the first if statement. Then obviously it will be going to terminate the first if statement, and then we will be going to print A, B, C. So here I am going to calculate that how many number of nodes are there and edges are there. So number 1, A is equal to 10 is the node number 1, node number 2, node number 3, 4, 5, 6, 7. So how many nodes are there? There are, I can say that 7 nodes, as well as how many edges are there? I can say that the edge 1, then here we are having the edge 2, then here you can see that edge 3, as well as here I can calculate as edge 4, and here we will be having the edge 5, then here the edge 6 is there, then edge 7 is over here, and in all at the end you can say that the edge 8. So there are in all there are the 8 edges and the 7 nodes. So this is what we are calculating with the help of the, I can say that the flow graph. Now as we are aware about how many number of nodes are there, how many number of nodes are there? 7. As well, how many number of edges are there? So in all there are 8 edges are there. As we are aware about both the values of the edges and nodes, so I would like to put up these values in the formula, and I will be going to get that cyclomatic complexity is equal to 3. So cyclomatic complexity is calculated using above control flow diagram and shows the 7 nodes and the 8 edges. So we will be getting the cyclomatic complexity is equal to 3. Alternate way you can say that CC is equal to P plus 1, where the P is nothing but it is the exit point, or I can say the how many conditions are there, predicates are there. So there are 2 predicates, 2 and plus 1 is equal to 3. So we can see that by method 1 as well as the method 2 we are getting the cyclomatic complexity is equal to 3. For preparation of this particular session, we have referred this tutorialpoints.com. Thank you.